Can celestial bodies in the universe be infinitely large? Is there a single star whose size can compare to the entire Milky Way? Earth is the largest object we can see with the naked eye, but compared to other celestial bodies in the universe, it seems insignificant. Jupiter is the largest planet in the solar system with a radius 1 time larger than Earth's and 317 times more massive. It is a gas giant with an internal composition similar to the Sun's, but because it has a small mass, its core, under the influence of gravity, only forms liquid metallic hydrogen and cannot undergo nuclear fusion. So, how big would Jupiter need to become a star? We can do a thought experiment. If we kept adding mass to Jupiter, its internal density would slowly increase, but the volume would not expand much. When adding about 80 times its current mass, the core would start to undergo intermittent fusion reactions, emitting a faint glow. However, at this stage, it would still not be a star, but rather a brown dwarf, a celestial object between planets and stars. This happens because its mass is not enough to sustain the pressure needed for continuous nuclear fusion. To form a star, we would need to add even more mass. By adding about 10 more times the mass to this brown dwarf, the core would reach the pressure and temperature needed for continuous hydrogen fusion into helium, releasing immense energy and becoming a minimum star, a red dwarf. Because it's easy to form, red dwarfs are the most common stars in the universe. If we added 90 more times the mass to a red dwarf, we would have our Sun. For stars the size of the Sun, slight changes in size can have a significant impact on brightness. For example, one of the brightest stars in the night sky, Sirius, is one of the most important stars besides the Sun. Astronomers use it as a standard to measure the brightness of other celestial bodies. Although its diameter is only twice that of the Sun, its brightness is 40 times greater. With a surface temperature of 10,000 degrees, Sirius is not the limit for the size of stars in the universe. The largest known star so far is R136A1, with a diameter 30 times larger than the Sun's, a mass 315 times greater, and a brightness 900,000 times higher. In theory, a normal star cannot be larger than R136A1, as the extreme nuclear fusion inside it would create a radiation pressure so intense that it would surpass gravity, causing it to explode. This limit is known as the Edington limit. In fact, R136A1 constantly loses mass due to stellar winds caused by radiation pressure, releasing 321 megatons of material per second. Normal stars cannot exceed the Edington limit, but stars in their final stages are not subject to this limitation. In about 5 to 7.5 billion years, the Sun will exhaust its hydrogen and turn into a red giant, expanding its diameter up to 256 times. From the perspective of the solar system, the Sun's volume occupies a small fraction of the solar system, but when it becomes a red giant, it will be large enough to engulf Earth. If a star larger than the Sun collapses, it could evolve into a supergiant. Currently, the largest supergiant observed is Stephenson 2-18, with a radius 2,150 times greater than the Sun's and a brightness 430,000 times higher, occupying the entire orbit of Saturn. Even at the speed of light, it would take 9 hours to orbit around it, while it takes only 14.5 seconds to circle the Sun. However, even supergiants cannot be infinitely large. They are subject to the fundamental laws of physics and would collapse or explode if they exceeded a certain size. However, there is a type of celestial body that can grow infinitely: black holes. The largest known black hole is TON 618, whose event horizon would take a week to cross at the speed of light. Inside it, several solar systems could fit side by side. Eventually, all the material in the universe could be sucked into a gigantic black hole, making it the largest star in the universe. In fact, every atom in our body came from a star that exploded. The atoms that make up your left hand may have originated from a different star than the atoms in your right hand. So, in a literal sense, you were once a star in someone else's eyes. Did you enjoy this fascinating explanation about the universe and stars? Then, don't forget to like, share the video, and subscribe to the channel so you don't miss more amazing content like this. Hit the notification bell to stay updated on the mysteries of the cosmos.